Okay, 5 minute or less forces review. A force is a push or pull on an object. What is a force? A push or a pull on an object. Two types of forces, two broad categories of forces, contact and field forces. Contact forces are in direct contact with each other, and field forces are not in direct contact with each other. Examples of contact forces are applied force. When a force is applied by a person or other object on another object, that is applied force and is abbreviated F sub A. Normal force is the normal, stable, supportive force exerted on an object that is in contact with another stable force like a chair, table, ramp, etc. And the symbol is F sub N for normal force. Friction force is the force that opposes motion as two objects move, slide across each other, or attempt to slide across each other. It acts in the opposite direction of motion. So we have motion in this direction, and friction is acting in that direction, opposite of the direction of motion. Static friction is when my pen is not picking up. Static friction is when there is no motion, the car isn't sliding down the hill due to the friction between the tires and the road. Kinetic friction is when there is motion, and we had the force of drag or air resistance, F sub D, is when something is free falling through air. The resistance due to those air particles is drag or F sub D. Tension force was the force at the opposite ends of string, rope, cable, wire, strap, etc. And we had cables. Right here's a cable between the ship. Here's a hose that was doing fueling between the ship. So we had the example of a person with a backpack on their shoulder. So here's my person, and they had a backpack hanging on their back by a strap. Man, this thing is really not cooperating. Ugh. Here's a backpack strap, and here's their backpack hanging off their shoulder by that strap. That was tension force. Field forces are not in direct contact with each other, and then we did some free body diagrams. Remember that force of gravity would be F sub G, and a supporting force, if an object was on a table, would be F N. And if there's an applied force moving the object in the direction of the applied force, and if you had an applied force, there would be friction in the opposite direction, F. And if it was moving, F sub K, and if it was not moving, F S for static. And another scenario is if we had a free falling body like an apple, it would be force of gravity bigger and drag would be smaller. In this case, if we had kinetic friction, the applied force would be larger than the kinetic force. And if it was not moving, then our static friction would be the same as our applied. Net force, you add them if they're in the same direction, so 6.5 newtons, and you subtract them if they're in opposite directions, so 10 newtons to the left, and subtract out 6.5 newtons to the right, and we end up with 3.5 newtons to the left. So that would be an unbalanced force. So there would be motion, there would be acceleration. If there is a balanced force, if the forces are equal, if your net force is 0, then there would be no motion, no acceleration. In this scenario, if got 5 to the right and 5 to the left. So we've got a net force of 0. The forces are equal, no motion, no acceleration. And down here we've got 8 to the right, 5 to the left. So 3 more newtons of force to the right. So there would be an acceleration towards the right, or motion towards the right. So on a piece of paper, I need you to turn in the answer to these questions. Question number 1. What is the net force acting on this object if you've got 5 newtons to the right? This is question number 1 on your own paper. You need to turn this into the box. This is your review quiz. And you've got 10 newtons to the left. What's your net force? That's question number 1. Remember, you can pause this. Question number 2. Free body diagram for an object that is being pushed right to left. So it's being pushed from here that way, right to left, across a desk. An object that is being pushed from right to left across a desk. Free body diagram. Number 3, what is the net force? Well, let's do acceleration. What is the acceleration? In this situation here, where we've got a 10 kilogram object with a net force acting on the object of 10 newtons. So 10 newtons. And the triangle for force, mass, and acceleration is this. Net force equals mass times acceleration. So then we know for solving for acceleration, we would be left with force divided by mass. So turn in the answers to those with the appropriate units into the tray, and then take your quizzes. Take forces Q, U, I, Z, I, Z, Z. Use your notes. Use slides. Take it until you get at least an 80.